For exercise number 5, we have to measure the height of the track. So just to show you, I'm looking at the track, the height of the track right here. So I've got a tape measure right here, and what we're going to do is measure from the bottom of the lab table up to the bottom of the track. Now, if you notice, the angle that the track makes with the horizontal, that has to do with the bottom of the track, not the top of the track, the bottom. Because it's the bottom of the track that hits the table, not the top of the track. So we must measure the height to the bottom of this track. So let's just do that. And so this is 10 centimeters here. So I have 10, 11, 12, 13, 14. It's between 14 and 15. 14.2, 14.4 is 14.4, I would say. So 14.4 centimeters is the height. So write that down. The height is 14.4 centimeters. Now let's actually measure the length of the entire track. So here's the end of the track here. I'm going to take my cart off. And there is actually measurement on there, but it doesn't go all the way, so I have to put my measuring tape along it to catch it. So it's at the end, and all right, so I don't know let's see if you can see it. So let me put it up here. So this is 1 meter. This is 1 meter, 0.2 centimeters. So 1.2 centimeters, I'm sorry, 1.20 meters, 1.21 meters, 1.22 meters. It's 1.228, it looks like. 1.228 meters. 1.228 meters. So let's just do a very simple calculation. Let's go over here. So I have here my height, length, that's the length. So the acceleration is g times sine of theta. Sine of theta is opposite over adjacent. The opposite, if you look at the track, the opposite is the height, and the hypotenuse is the length. Opposite over, did I say opposite over adjacent? Sine of theta is obviously opposite over hypotenuse. Sorry about that. Tangent of theta is opposite over adjacent. No, actually, opposite over adjacent, that would be cotangent. Anyway, I said that wrong. So sine of theta, the definition of sine of theta is opposite over hypotenuse. So what we can do to find the acceleration is take g, which is 9.8 meters per second squared, multiply it by sine of theta, which is the opposite, 14.4 centimeters, divide by the height, which is 122.8 centimeters. You have to make sure you're in the same units. We're going to cancel out the units, so you can either put them in meters or you can put them in centimeters. Just make sure it's in the same units, and then you can cross out the units and you just calculate it. So I have 14.4, I divide that by 122.8, then I multiply that by 9.8, and my acceleration becomes 1.15 meters per second squared. Okay, so that's the theoretical. And again, it is a measured value. I did measure the height and the length. But if there were no friction, if there were no sound, then your experimental value should be quite close to that. But as you found out in exercise number 3 and exercise number 4, the acceleration you actually got experimentally is lower than this value. And that's it.